The ocean is an enigma, a vast, powerful entity that covers more than 70% of the Earth's surface and remains largely unexplored. While humans have ventured to the moon and deep into the Earth's crust, the ocean depths remain one of our last great frontiers. Despite being integral to the Earth's climate, ecosystems, and even our own survival, the ocean is a space that we have only begun to scratch the surface of. Today, over 80% of the ocean remains unmapped and unexplored. What mysteries lurk in the inky depths? How does this unknown world influence our own lives, and what are the potential discoveries yet to be made? Beneath the waves, the ocean harbors a world so alien to human senses that it seems almost otherworldly. From the mysterious creatures that glow in the dark to the ecosystems thriving around underwater volcanoes, the deep sea is unlike any environment on Earth. This vast and unexplored territory is a window into the unknown, and as we venture further into the abyss, we begin to understand that the ocean is not just a collection of water, it's an intricate, dynamic system with its own rules, mysteries, and significance. The ocean's structure. The ocean is not just a vast expanse of water. It is a layered system, with each layer supporting different types of life and environmental conditions. These layers, from the sunlit surface to the pitch-black depths, are known as oceanic zones. Each zone plays a critical role in the overall functioning of the marine ecosystem and offers insights into the adaptability of life on Earth. The sunlit zone. The uppermost layer of the ocean, known as the epipelagic zone or the sunlight zone, extends down to around 200 meters. Here, the sunlight is still able to penetrate, supporting photosynthesis, which in turn sustains the majority of marine life. This zone is not only home to the coral reefs, which host diverse marine species, but it also supports the commercial fisheries that many coastal communities depend on for their livelihoods. The phytoplankton that float near the surface of the ocean are the true heroes of the food web. These microscopic organisms photosynthesize, absorbing carbon dioxide and releasing oxygen, which contributes to around 50% of the Earth's oxygen supply. They form the foundation of the food web, feeding small zooplankton, which in turn are consumed by larger fish, which support even larger predators like sharks and whales. In this zone, we also find the most familiar ocean life: dolphins, sea turtles, various species of fish, and even whales. Coral reefs, which exist just beneath the surface in tropical waters, are among the most biodiverse ecosystems on Earth. Despite covering less than 1% of the ocean floor, they support approximately 25% of marine life. However, the sunlight zone is not just about life, it's also an area of intense human interaction. Scuba diving, recreational fishing, and tourism all take place here, providing millions with access to the wonders of the ocean. The twilight zone. Beneath the sunlight zone, we enter the mesopelagic zone, also called the twilight zone, which extends from about 200 meters to 1,000 meters deep. Here, the last rays of sunlight filter down, but they are faint and do not support photosynthesis. As a result, this zone is largely reliant on the marine snow, organic matter that falls from the upper layers of the ocean, such as dead plankton and decaying plant material. This limited food source dictates the survival strategies of the creatures that call the twilight zone home. The creatures of the twilight zone are remarkable in their adaptations. Many of them are bioluminescent, producing their own light through chemical reactions within their bodies. This bioluminescence serves several purposes: attracting prey, camouflaging from predators, and even communicating with one another. Some fish, such as the lanternfish, possess large eyes to help them detect the faintest glimmer of light, and their bodies often have reflective scales that help them blend in with the dim surroundings. At these depths, the animals are often strange and eerie-looking. Anglerfish, for example, have a long, bioluminescent lure extending from their heads to attract prey in the dark. Other species, like the bristlemouth, are among the most abundant vertebrates on the planet. These creatures live in extreme darkness and rely on specialized adaptations to survive. The twilight zone is a transitional space between the well-lit, vibrant upper ocean and the deep, abyssal world below. It's here that we start to see a marked difference in life forms, with many species exhibiting unique anatomical features, like enlarged eyes or glowing organs, that are necessary for survival in a world without light. Interestingly, whale falls, the carcasses of dead whales, also provide rich ecosystems in the twilight zone, feeding hundreds of species of scavengers and decomposers. The midnight zone. At depths beyond 1,000 meters, we enter the bathypelagic zone, also known as the midnight zone. This region is completely devoid of natural light, and the creatures that live here have adapted in extraordinary ways. The pressure is intense, over 100 times greater than at the surface, and the temperatures hover just above freezing. This is a space where life has had to evolve to survive extreme conditions. Creatures in the midnight zone are often slow-moving and energy efficient, conserving every bit of energy due to the scarcity of food. Anglerfish, giant squid, and deep-sea octopuses are just a few of the animals that roam this deep, dark world. The giant squid, a species that has long been the stuff of legend, can grow up to 12 meters in length. These creatures remain largely elusive, and many of the encounters with them are the stuff of myths and maritime folklore. Some species here, like the gulper eel, possess massive mouths capable of swallowing prey larger than themselves, while others, like the viperfish, have large, sharp teeth to trap their food. Adaptations to the lack of food and light often include enormous eyes for detecting any available bioluminescent signals and extensive neural networks to process this information. Even though the environment is incredibly harsh, life flourishes in the midnight zone. The bioluminescence seen here is even more complex than in the twilight zone, with some species capable of using their glow to confuse predators or lure an unsuspecting prey. The abyssal zone. Beyond the bathypelagic zone lies the abyssal zone, which extends from around 4,000 meters to 6,000 meters deep. This zone represents the deepest parts of the ocean and covers much of the Earth's ocean floor. The environment here is inhospitable, temperatures are near freezing, and the pressure is immense, around 400 to 600 times greater than at sea level. The abyssal zone is almost completely dark, and the lack of light, warmth, and food has led to fascinating adaptations. One of the most interesting phenomena in this zone is deep-sea gigantism. Animals in the abyssal zone tend to grow to larger sizes than their shallow water relatives. The giant isopod, for example, is a type of crustacean that can grow to over 30 centimeters long, resembling an enormous underwater cockroach. Similarly, giant squid and deep-sea fish exhibit extreme adaptations, including slow metabolisms that help them conserve energy in such a resource-poor environment. Life in the abyssal zone is primarily supported by chemosynthesis, a process by which bacteria use chemicals like hydrogen sulfide and methane to produce energy, rather than relying on sunlight. Hydrothermal vents, which are found in various parts of the deep ocean, support entire ecosystems that rely on these chemosynthetic bacteria as their primary energy source. These vents are often surrounded by communities of tube worms, clams, and crustaceans, all living in this extreme environment. In some areas of the abyssal zone, deep-sea mining and oil exploration are putting these ecosystems at risk, threatening species that may hold answers to some of Earth's greatest scientific questions. The Hadal Zone. The Hadal Zone lies at depths greater than 6,000 meters. It includes the deepest trenches on Earth, such as the Mariana Trench, home to the Challenger Deep, the deepest known point on Earth, which plunges to around 10,928 meters. The pressure at these depths is 1,100 times that at sea level, and the temperatures hover just above freezing. Despite these extreme conditions, life still manages to exist in this dark and seemingly inhospitable environment. Explorations into the Hadal Zone are rare and technologically challenging, requiring submersibles capable of withstanding the immense pressures. The 2012 dive by filmmaker James Cameron to the Challenger Deep in the Deep-Sea Challenger submersible was one of the most famous expeditions to this region. Cameron not only recorded new species but also collected valuable scientific data on the geology, microbiology, and hydrodynamics of the trench. More recently, in 2019, explorer Victor Vescovo set a record by descending to Challenger Deep, documenting new species of creatures and even finding evidence of human pollution, plastic bags and wrappers, at the deepest point on the planet, highlighting the pervasive reach of human impact even in the most remote places on Earth. The deep ocean represents one of the final frontiers of exploration on Earth. It is a place that challenges our understanding of biology, geology, and the limits of life itself. As we continue to explore the depths, we discover more about the history of our planet, the evolution of life, and the potential future of scientific innovation. While our knowledge of the ocean is still in its infancy, each expedition into the deep reveals new secrets, some thrilling, others humbling. The deep sea is more than just a mysterious world, it is an integral part of the planetary system that sustains life on Earth. As we venture deeper into its realms, it is our responsibility to not only discover but also protect the wonders it holds. The ocean is vast, but as we continue our journey into its depths, we may come to realize that the greatest discoveries still lie beneath the waves, waiting for us to uncover them.